What are atoms? How are atoms discovered? What is the historical development of atoms? Who are the pioneers that actually discover what an atom is? And who are those that describe the atomic theories? And who are those that propose the atomic model? These are the questions that we'll be looking at in today's video, which means for today's video, we'll be looking into the historical developments of atomic models as well as the concept of atomic theory. The development of atomic models was dated back to 400 BC during the time of two Greek philosophers, which is a teacher known as Leucippus and his pupil, which is Democritus. Leucippus and Democritus worked on the concept of atom, and they noticed that there is a smallest indivisible particle called the atomos, and they are referred to this thing as the atomos. And atomos means what? It means smallest indivisible, which means something that cannot be divided. So they describe an atom as something that is indivisible. They look at it in a concept like, if we have a yam, for example, if we have a yam like this, we can cut this yam into two. These two, we can cut it, we can keep cutting, to the extent that we have a very small one that our knife cannot cut anymore. And this small one is described as what? As atomos of that yam, which means the smallest particle of that yam that cannot be divided anymore. And that is where the concept of atom come from Leucippus and Democritus. These are the two philosophers that talk about atom first. After hundreds of years, there come an English philosopher or an English chemist, which is John Dalton. John Dalton is believed to be the father of atomic theory itself, because he considered that all matter composed of small particles called atoms, and he visualized atom as a very hard solid individual particle that is incapable of subdivision, which means he says atom cannot divide. So according to him, he now proposed atomic theory using this paper that he proposed in the year 1805. According to him, we now have that all matter composed of atom, or all matter is made up of a smallest indivisible particle called atoms. Atom of a particular element look alike in every manner, and they are different from atom of other elements in every manner as well. Atom of a particular element cannot be converted into atom of any other element, according to Dalton. And he says compounds are combination of two or more different types of atom, and a chemical reaction is a rearrangement of atom itself. This is the proposal of Dalton atomic theory. Now, are these things right? Are they really correct? These are the questions that the modern scientists actually ask themselves in the 19th and the 20th century, that give rise to enormous or different types of atomic theory as well as different type of atomic model. And we are having pioneers like Sir Thomson, Rutherford, we'll be talking about very soon. Now, we now have, from our discovery, we know that atom is no longer the smallest particle of a substance, because atom also consists of three fundamental particles, and these three fundamental particles are called the proton, the neutron, and the electron. So this proton, neutron, and electron, they have their own properties. But how are these proton, neutron, and electron, how are they discovered? It is from the question, are atoms really the smallest particle of an element? That is the question that scientists is trying to answer, that give rise to the discovery of these subatomic particles. Don't get me wrong, we have enormous large number of subatomic particles, but the most important ones is the proton, the neutron, and the electron. So let us get into a fascinating story in the discovery of these subatomic particles. It should be noted that the main landmark in the evolution of atomic structure includes Sir Thomson in 1896, Ernest Rutherford in 1909, Moseley in 1913, Bohr in 1913 as well, Chadwick in 1932, and we have some scientists also like Goulston and Robert Millikan in 1908. which we'll be talking about very soon. What are the contributions of these scientists to the development of atomic theory, and what are the contributions of these scientists to development of to the discovery of subatomic particles? This is a man called Sir J. J. Thomson, and in the year 1896, Sir J. Thomson performed an experiment called the cathode ray experiment, or the discharge tube experiment, where he used this experiment to discover the presence of electrons. What he did was, this is a setup. This is Sir J. J. Thomson, if you'd like to visualize his picture, and this is the experimental setup. So he used a cathode ray, and before then, cathode is not known to be a negatively charged particle. You understand? So this is a cathode ray. You understand? So this is a cathode source. He made a cathode ray to pass through this side, and as it is going through, we have the positive electric field, the negative electric field, the south pole magnetic field, and the north pole magnetic field. So what happened is that, in a nutshell, he noticed that the ray proceed from the cathode ray and move away from it at a right angle in a straight line called the cathode rays. Like they move away from the cathode source at a right angle. And what do they move towards? They move towards the negative electric plates and the south magnetic field plates. You understand? And we know that the south magnetic field is just like negative magnetic field plates. So according to the law of electricity, general law of electricity, we know that like charges repel and unlike charges attract, which means for something to repel a negative charge and attract a positive charge, it means that thing must be negative. So this man concluded that, which means cathode rays are negative rays, and he gave properties to these particular rays, like he gave conclusions to these particular rays of this thing. This is also what you have in here as well. If you look at it very well, you see that as this thing is moving from the cathode source, moving through these plates, you will see that it's moved towards the what? It's moved towards the positive plate downward. Can you see? Towards the positive plate. Can you see it now? So that is what this man did, and he noticed that the cathode ray are negative charge. Now he performed three experiments. The first experiment, Thomson demonstrated that cathode rays have negative charge. That is the first experiment. That is experiment one. The second experiment, he investigated whether these rays can be deflected by electric field and magnetic field, which we have seen, where the cathode ray is deflected towards the positive plate on the electric field and south pole on the magnetic field, right? And he also notes the experimentally he measured the mass to charge ratio of cathode rays. He measured the what? He measured the mass to charge ratio of a cathode ray, and according to him, the mass to charge ratio is 1.76 times 10 raised power 8 coulomb. 1.76 times 10 raised power 8 what? 8 coulomb per gram. That is charge per mass of an electron, according to Sir J. J. Thomson. So this is the experiment of Sir J. Thomson. Now, what are the properties of cathode ray that Sir J. Thomson actually mentioned? The first thing is that they travel in a straight line away from the cathode source, and they cast shadow of metallic object placed in their paths. The second thing is cathode rays cause mechanical motion of small pinwheel placed on their path. The third thing is that they produce fluorescence when they strike a glass wall of the discharge tube. Remember, it's a discharge tube experiment. The fourth thing is they heat up a metal foil to incandescence, which they impinge upon. And the fifth thing is cathode rays produce X-ray when they strike a metallic object. And the last and the most important thing is that they are deflected by electric as well as magnetic field, deflecting towards the north pole in electric magnetic field and deflecting towards the what? Towards the positive pole in the what? In the electric field, right? So those are the properties of what? Those are the properties of cathode ray. So because they are deflected towards the positive plate, hence they are negatively charged, because unlike charges does what? Unlike charges attract. Now, after the discovery of electrons, Sir J. Thomson comes about the first atomic model, the visualized atomic model called the Plum pudding model. And according to him, he said that an atom is like is like a ball, a spherical body, you understand? And this spherical body has a negatively charged and a positively charged embedded in a sphere. You understand? This is Plum Holding model. But is this model really right? Is it really logical? That is what the next question is actually answering, and that is Sergey Thomson, which we won't move to that one yet. But what you have to note is that if we have something like positive and negative in a sphere, what is going to do is that they are going to attract each other. And once they attract each other, they are going to become concentrated at the center. And once it's concentrated at the center, there can be emulsion and the atom is going to burst. And remember that they said atom can neither be created nor destroyed, nor it cannot be changed from atom of one element to the other, which means this atom has been what? Has been totally destroyed. So it does not explain the stability of what? The stability of an atom. So his model does not explain the stability of an atom, so it was discredited because of this. Even though the discovery of electron won him a Nobel Prize in a certain year. So let us move to the next thing. Then we have a man called Robert Millikan. What Robert Millikan did was, you know that Sir Thomson discovered or he calculated the charge per mass of an electron. So what Robert Millikan does is they call it Millikan's oil drop experiment. And this is Millikan's oil drop experiment. He used oil drop, the X-ray, telescope, oil spray, light supply, and other stuff like that. What he does is that using after he concluded that what we can use to calculate the charge of an electron is Q equals to Ne itself. That is what he used to calculate the charge of an electron. And according to him, the value of the charge of an electron is 1.6 or minus negative 1.6 times 10 raised to power minus 19 coulombs, just approximately 9.1 times 10 power minus 19 coulomb, but it is negative 1.6 because it is an electron. Now remember that for charge per mass of an electron, it is 1.76 times 10 power minus 8 coulomb per gram. You understand? Now using these two values, we can actually get the mass of an electron. So we can use this one to get the mass of an electron as well. And the mass of an electron is said to be 9.1 times 10 raised to power minus 28 gram, or 9.1 times 10 raised to power minus 31 kilogram. You understand? So we have them like that. So 1.76 times 10 raised to power 8 coulomb per gram is the charge per mass of an electron that is discovered by what? By Sergey Thomson. 1.6 times 10 raised to power minus 19 coulombs is the charge of an electron that is proposed by who? By Robert Millikan using oil drops experiment. And according to him as well, he also stated that the mass of an electron is 1 ratio 1835 mass of hydrogen. That is the mass of electron. Mass of electron. You understand? That is the mass of electron itself, according to Robert Millikan. Now, moving on to the next man, which is Ernest Rutherford. Ernest Rutherford is the person that actually proposed the nuclear model of an atom. And what this man does is that what? He discovered the nucleus itself. It was Rutherford and his partner Martin in the year 1909. They perform an historic alpha particle scattering experiment, and this is the experiment that they perform. What they did was that what they needed an alpha source. Remember that an alpha ray is a positive ray. You understand? So what they discover is that what is that as this thing is that they have a gold foil. Can you see there is a gold foil here? So they bombarded the gold foil with what? With alpha particle, with alpha rays. Now they discovered that almost all the particles were able to pass through the gold foil, except few of them. Except what? Except few of them that deflected backward at an angle greater than 90 degrees. They did not deflect at an angle at a 90-degree angle. They deflected at an angle greater than 90 degrees. You understand? Now, he now asks himself, what has happened? Why has this thing happened? Why does this thing deflected backward at an angle greater than 90 degrees? And that is where he actually realized that there is a positive charge at this place that is capable of deflecting the positive charge alpha ray. Let us visualize it. He says that if you're having something like this, we have the alpha source here. This is alpha source, right? And we have the gold foil. And we bombard this gold foil with an alpha rays. Most of them were able to pass through, and few of them deflected backward at an angle greater than 90 degrees, which means there's something at the center that causes the deflection. And since alpha rays are positive rays, it means something that causes the deflection at the center as well is also a what? It's also a positively charged body, and he called that positively charged a what? A nucleus. So this is how his own model looks like. So he said, which means an atom is an empty space that is having a concentrated center, which is a nucleus, and the empty space, which is the volume of the what? The volume of the atom, is having a negatively charged that is surrounding it, that is revolving around it, just like the sun revolves around the planets, just like the planets revolve around the sun. And they call this model planetary model of an atom. So this is planetary model of an atom, and that is the reason why as alpha ray is coming through, they are emitting negatively charged, so they are able to pass through. But when they reach this center, which is the nucleus itself, when positive meets positive, that is alpha ray, which is positive, meets an alpha, which means it meets a nucleus which is also positive, it deflected backward at an angle greater than 90 degrees, and that is what Sir Ernest Rutherford actually concluded on. So, what is the main conclusion of Ernest Rutherford? Who are those that actually work further on the discovery of atomic model and also the discovery of subatomic particles? We have mentioned the one for nucleus, we have mentioned the one for electrons. Who are the other ones that work on it? These are the questions that we'll be answering in our next video, and in the next video we'll be talking about it much more better. Thank you so much for listening. Don't forget to like, to share, and to subscribe. Thank you all.